Hi there, my name is Ovila Bird. I'm the Road and Bridge Supervisor for Flathead County. It's a beautiful spring day. In that spring day, our attention turns to gravel road maintenance. We're going to show you a little bit of how to maintain a gravel road. In that process, we will water the road. We will use a grader to cut that road, to bring the shoulders to the center, to work that gravel out to the edges again, define a 4% crown in that road, and the final product should be a well-maintained gravel road that the public can travel safely, and you end up with a process that is easy to follow and it will have a sound and very productive result.
And my name is Steve Jenkins. I direct the LTAP program. Ovila Bird and I have teamed up today to give you a few tips and a few pointers on spring maintenance, on how to blade your roads. This is really a process perfected by Flathead County and probably similar to what a lot of you do. So Ovila, today we're going to go through this process, and I just want to ask you a couple of questions. First of all, it's springtime, probably the right time of year to pull some of that shoulder material back onto the roadway. There's going to be vegetation with that. How do you deal with that vegetation?
Well, the process is once you pull that vegetation onto the road, you need to work that vegetation back and forth on the road to knock the gravel out of it, to knock the dirt out of it, get the fines out of it. That vegetation eventually becomes just vegetation with no gravel. It's easier to discard that on the shoulder of your road, get rid of it. And in that process, you gain the gravel and the fines to make your gravel road hold together.
To make your road better. So the process then is pull the shoulders, do several cut passes on each side until you've worked out the defects. Remix that material and pull it into the center and prepare for your 2 spread passes or layout passes. So we'll go through that today. You caution your guys about leaving a berm on the shoulder of the road. First of all, what's the problem with that berm, and then how do you prevent it?
Well, 2 things are difficult to accept about a berm on the side of your road. For one, it does not let the water escape that level of that surface of the road. It forms a dam as such. The other is you're wasting gravel. You're not utilizing that gravel by allowing the public to travel on that gravel if it's in a berm on the side of your road. So we try to tell them to keep the gravel on the road, in the crown, in the traveling surface of the public.
Okay. You also mentioned that in their layout pass, the heel or the trailing edge, if they see a lot of material spilling there, they should straighten out their blade to more of a flat blade. And with that, they'll pull more of the material into the center. Also, they can lift their blade a little bit to let more go underneath. So what we're hoping to achieve is a 4% crown. How do you know that you've got a 4% crown?
Well, in all of our blades at Flathead County, we put a slope meter in there in the visual eye of the operator, so that when he's making his passes, he can visually check that slope meter periodically and find out where he is at. We tend to keep our roads, or try to keep our roads, at a 4%, as high as a 6%, as low as a 2%. That allows the water to drain off that road sufficiently, and we all strive for that.
Good. And a 4% is a 1/2 inch per foot of slope or crown on that road. So with a 12-foot lane, it's about 6 inches of fall. And we'll show you today a very simple method to check that once you're done grading the road. So that's what we're going to try to achieve today, and we'll have a little bit of time after to talk about it. Again, thank you, Ovila, and thanks Flathead County for allowing us to be here and to film their process that they've worked so hard to achieve.
Thank you.
Ovila, another very important issue on gravel roads is the proper material. Most counties try and achieve that, and it's a little more complicated than just looking and saying that's good material. We would really like them to buy a set of sieves so they can be able to analyze what material is good and what is not acceptable. I guess that if they had a set of sieves, they could then meet the spec that Montana recommends and the Montana LTAP Center. You've had some challenges and struggles lately with contractors trying to get them to produce that material. How's that gone for you?
For the most part, pretty good. We definitely have to check on them weekly go to their final belt at their crusher and take a sample, the 5-gallon bucket, bring it to an engineer and have him find out if they're meeting the spec on that.
Okay. The top sieve that we recommend is a 1/2-inch sieve. And this is critical that when we look on top of that sieve, the material that's larger than a 1/2-inch has a good percentage of fractured face. Mm-hmm. The next sieve that we look at is a number 4 sieve, less than 4 openings per inch. And we also want an equal amount of material on that sieve. The next sieve is the number 8, less than, 8 openings per inch. Some of that material is here, and again, we want that all to be fractured. Now, I would rather have fractured faces and a little finer material than large rounded rock that's always going to move and always going to be a problem on a road surface. The last sieve that we have is the number 40 sieve. Everything that passes through that 40 sieve is either a silt or a clay. We need that clay, we need that binder on the road surface to hold it together. And I guess your contractor didn't really want to do that because it was messing up his crusher. It's okay if they set that overburden aside and then bring the clay in after they've crushed. Did he have some trouble with the spec that we require or would like to see?
Yeah, he did. Specifically, we had that plasticity was added to our gravel through bentonite. That's what we needed to add. The bentonite tended to, like you said, Steve, wanted to plug up his crusher.
Yeah.
So he did exactly that. He would add the bentonite, the very last thing on the very last belt, right, before it entered the stockpile. Bentonite's not cheap where we live, so it was a tough sell, but yeah, I think our final product turned out okay.
Good. One more point. You called and asked if you should reject that material that didn't exactly meet the spec. Well, that's not always the case. If that's the best material you have available, use it. And you might be able to get that for a discount if it's not meeting our spec through negotiations with the contractor. Well, again, thanks a lot for your experience, Ovila. Thanks for your help, and let's go out and see how we can work this road.
Thank you, Steve, for being here. What we want to accomplish here is to bring in the segregated material on the road, and in that process of bringing in the segregated material, we want to cut out the washboards, cut out the chuck holes, and then we want to restore the crown to that road. So our final product is a 4 to 6% crown. In that process, we will water the road, get our moisture at optimum, and then as soon as we receive that moisture on our road, we want to start our grader, cutting the shoulders, bringing that material to the center of the road. And like I said, implementing the segregated material into the material that's on the road, cutting in that same process, cutting out the washboards and the chuck holes, and defining the crown. The process of blading a gravel road is to not only establish the crown, but first of all, you need to take the segregated material that's usually alongside of the shoulder of the road and implement that into the gravel that is existing on the road. And in that process of pulling that segregated material in, you need to cut out your washboards, you need to cut out your chuck holes, and final product is to define a 4 to 6% crown in that gravel road. We are now going to start our water truck watering the gravel road, so that is the first and foremost thing that you need to have before you do any gravel maintenance. You need to have the proper moisture. We have a water truck that will come down and water this section of our road, and we will start the process. In the process of maintaining a gravel road, you need moisture. Sometimes you can get it through rain, but a lot of times you have to rely on water trucks. In that same process, that water truck needs to water your road. I don't believe that you can receive enough water if the day is warm, if the day is dry. You apply that water previous to your blading, during your blading, and after your blading, you'll end up with a final product just like you desire. Next process is the blade. You need to bring the grader on the shoulder of the road, mixing that segregated material that we talked about earlier. And while he's mixing that segregated material, he's also cutting the floor of the road. While he's cutting the floor of the road, he is knocking out the washboards, the chuck holes, and mixing the segregated material with the material on the road. As you can tell, he's trying to maintain that 4% grade, 4 to 6% grade as he makes that cut. He has his blade angled where he pulls that gravel into the center of the road. As you can tell, he's made one pass down that shoulder. He will then turn around, come back and make a pass down this shoulder, all the while bringing that gravel to the center of the road. If he cannot cut the full width of that road in those two passes, he will make another pass and bring that berm closer to the center on each pass. That way the full entire surface of that road has been cut. It may be necessary at times to run your grader against traffic. We like to think at most times we would like to keep that blade running with the traffic. It's a safer, more effective way of blading. Every blade man has their own style that they run, that they take. We like to think that our blade men can stay with traffic, put their signs out. It allows them a safer form of travel, allows the public to meet and pass that blade safely. That is our choice. He's now making his second pass, cut pass. As you can tell, his windrows are not together, so it might be effective if he makes another cut pass down that far side and this side to make sure that the whole surface of the road has been cut. You might have noticed the picks that we're using for a cutting edge. We call them a button bit. A lot of people call them a picks. We at Flathead County use those on all of our blading for gravel roads. We also have obtained walk-and rolls for the rear of our graders, and we use those to compact the material as they blade. The final process, it's a great final product that we end up with the walk-and rolls. It seals that moisture in that top 2 inches of gravel. We're now having the water truck come, apply a little bit more water. It can get dry if you make those initial cuts. As you can see, the gravel has dried out some. A little bit quicker shot with the water truck this time. We don't want to saturate it too much and turn it to mud. Then the grader will follow up. As you can see, we're using the walk and roll behind that grader. It's a wonderful process that allows that cut gravel to be compacted as he's blading. He not only compacts it on his cuts, but he can compact that while he's doing his final blading. The advantage of having the grader run in its own lane of traffic is if you have the public traveling the road also, It allows that public to not be confused and allow them to proceed on their journey without being interrupted. It also alleviates us having to have flag people with every grader blading gravel roads. The grader now is making his last cut pass, which would allow all of that gravel, that berm of gravel, to be placed just beyond the center of the road. He will then turn around and start his layout. The blade now is making his last cut pass. It will allow him to place that material beyond the midway of the road, the crown of the road. And once he turns around again, he will be doing his final layout passes. Again, you can see he's using his walk and roll. He's still cutting, but he's allowing himself to compact that lower level of gravel. Walk and rolls are essential. The blade now is making his initial layout pass. And in that initial layout pass, it is really important for him to maintain that 4 to 6% grade. If he can define it right now, it will become much easier on his second layout pass. The wetness of our gravel is essential too. He has his walk and roll down, but if that gravel is not wet properly, all of this is in vain. You need that water for that compaction. As you can see, he's got his walk and roll down, and he is maintaining his 4 to 6% grade. As you can see, the moisture in this gravel is pretty extensive. We have found that if we can get that gravel to have that amount of moisture in it, when it finally sets up, you get that crown, when it finally sets up, it gets a thin crust on it. If you can receive that thin crust, that eliminates your dust problems, it eliminates the loss of aggregate, and your road will stay smooth for a much longer period. Something to be mindful of is traffic control. As you can see, we have a hill just previous of our work zone. We have set our signs out at a safe distance to allow the traffic to see us working. He is now making his final blade pass, final layout pass, and you can see that it is essential for him to not allow that gravel to end up in a berm on the side of the road. He is not allowing that gravel to form a barber chair to allow that water to stay on the road. The other process that he is doing is, you can see in the driveway here that he has met this driveway. Again, keeping that 4% crown. Final grade has been achieved here. He not only did his 4 passes to get it to the center, he is now doing his final grade, which is a good 4%. Not leaving any gravel on the shoulder of the road.
One very important aspect of this gravel road is the gravel that goes into building it. These are the building blocks that help us with bearing capacity. Another important factor is to eliminate all of the air voids if possible. You can see on this top screen, the 1/2-inch sieve, most of the material that we have, or that Flathead County has fractured faces, more than 90%. The next screen is a number 4 sieve, and you can see the same thing, quite a bit of good material with fractured faces. The third screen is the number 8 sieve, and we've got the same thing here. Now those top 3 screens should be about equal. What's retained on those 3 should be similar. The other half of our material is fines. What's retained on and passes through the 40 sieve. You can see that material fills in a lot of the air voids and helps build a good road. What passes through the 40 sieve is either a silt or a clay. We need some of that material to help the road bind together. You can see without moisture, it looks a little bit more like just silt, but when we add some moisture, that may provide the binder that we need. If you look down at how this road is constructed, the base of the road has larger rock, and it's okay if a lot of that rock is rounded. A lot of these rocks were in riverbed quarries where the rock rolled down the river and took on this rounded shape. But up near the surface, we need a finer rock and we need a lot more fractured faces. All of these factors help to build a design road that's going to be permanent and help us to avoid movement in that surface.
Here we are checking the final grade of our gravel road. Looks to me like about a 7-inch fall, which would give us about a 5% grade. Us at Flathead County, we like a 5% or 6% because we know eventually that it'll probably work into a 4%. With our moisture being optimum and our crown being optimum, this is just exactly what we like to see at Flathead County. I appreciate you coming out with us today here at Flathead County. We know that everybody's process when they blade a gravel road could be different. It's the final outcome that is what is really important. Thank you for being here. We appreciate you being a part of this. And unbeknownst to us, I believe we have 3 county commissioners that has watched this whole process.